All right, guys, today we're gonna have a demo day. We're gonna do a couple different demos. So on your paper, which is page 25 of your notes, first thing you gotta do is the pre-lab. So if you haven't done the pre-lab yet, pause it, do the pre-lab, and then you can press play. All right, so I have a few things here we're gonna do. We're gonna look at different types of chemical reactions today, because that's what we've been learning about is chemical reactions. So first thing I'm gonna do is I'm gonna see if I can get my fire to light up here. There we go. You can see my pretty flame. Looks good. Okay, so first one we're gonna do, if you look at where it says observation/data, is a synthesis or combustion reaction. So it's gonna be both synthesis and combustion, because remember, it's possible for a combustion reaction to also be considered synthesis. So what we're gonna do is we're going to take magnesium, as you can see, solid magnesium, and combine it with oxygen. This is the magnesium we're going to start with. Can you see it? So you need to write your observations before the reaction. It just looks like a thin silver piece of metal, okay? I'm going to put it in the flame. That's what it means by combine with oxygen, okay? We're gonna put it in the flame. If I can get it to work properly. I'm gonna use tongs so I don't burn my fingers. All right, here we go. And you tell me what you observe. All right, what do you see? I dim the lights a little. It's bright, right? Ooh, hurts my eyes a little bit. All right, we got a bright light. Okay, we got a bright light. So after the reaction, let me show you what it looks like after the reaction. Okay, now that our reaction is over, it looks like this. This is what it looks like. It's not shiny anymore. It's kind of brittle and white and ashy looking, okay? So that's what it looks like after the reaction. This would be our product, okay? This would be our product. Okay, that was our synthesis/combustion reaction. So that one was categorized as synthesis and combustion. So based on our reactants, magnesium and oxygen, you can figure out what our product is going to be, okay? So decomposition. What we're gonna do in a decomposition reaction is copper to carbonate. It looks like this, it's a green powder. I'm gonna put some in a test tube. Okay, I'm gonna put some copper to carbonate in a test tube and I'll show you what it looks like. It's a green, solid, powdery substance. And we're gonna do a decomposition reaction. A decomposition reaction. Now remember, in a decomposition reaction, we always only have one reactant. So we're not mixing this with anything. We're not gonna put it in the flame. Okay, this is our only reactant, all right? All right, let me show you so you can get a good look of what this looks like. Scoop that over. This is what it looks like, a green powder. A green powder, okay? All right, so now to get this reaction going, I'm gonna heat it. I'm gonna heat this in my Bunsen burner here. This isn't technically a Bunsen burner, this is a camp stove. You can buy it at Walmart or REI. And I'm heating up, notice I'm using a test tube holder, I'm not using my bare hands, because that would hurt, right? Okay, and if you can see, it's not green anymore. I'll give you a closer look here. It's like I'm just shaking it. Just shaking it. Trying to get it evenly distributed. Now this is a decomposition reaction. So we started with copper to carbonate. Now remember, when we have a decomposition reaction with a metallic carbonate, what does it make? Look at page 24 of your notes. It tells you what it makes when you have a metallic carbonate in a decomposition reaction. Does it still look like a green powder? Nope, it doesn't. It looks black now. It is no longer copper to carbonate. It's something different. This would be our copper oxide. So we made two products. One of them was copper oxide, copper to oxide. The other one was carbon dioxide, which you can't see because it's a gas, okay? All right, so that was our decomposition reaction. All right. Okay, the next reaction we're gonna do is a single replacement reaction. Okay, and the single replacement reaction, we're gonna take a piece of zinc, okay, and we're going to take some hydrochloric acid, which is HCl. Okay, this is a pretty strong acid. We don't mess around with hydrochloric acid. So I got my gloves on, got my goggles on. If this stuff, enough of it gets on your skin, it can give you a really bad chemical burn. I think this is the same acid that exists inside of our stomachs to kind of digest our food. And this is a really strong concentrated solution I got here. Okay, so I've got hydrochloric acid. I'll show you what it looks like. Looks like this. It's just a clear liquid. So that's the appearance that you can mark on your paper. Okay, and then the zinc. Looks like this. It's just a little piece of metal. It's solid, kind of heavy. Okay, a piece of shiny silver metal. It's a zinc though, it's not silver. That'd be expensive. Okay, so now I'm gonna add it. Okay. And as soon as I added it, look what happened. You see there's like a gas coming out the top and there's bubbles. So how do you know a chemical reaction's happening? I see bubbles forming. Okay, there's definitely a gas being produced. So this is a single replacement reaction. So the zinc is gonna swap places with either the hydrogen or the chlorine. It's gonna switch places with the hydrogen because the hydrogen is the positively charged thing. So instead of zinc being by itself, now the hydrogen's by itself, and that is the gas that's being released. Okay? And this is how we're going to test to see if sometimes this works, sometimes it doesn't, so stay tuned. All right, I've got a match. Let's see if it's gonna work. You hear that noise? That noise indicates there is hydrogen gas coming out. And that's kind of why it flickered and flashed for a minute. So we'll let it produce a couple more bubbles and we'll try it again. Listen carefully for the sound. Do you see this? Can you see it? Maybe you can't. But there's definitely, oh, there you can see it. Some gas being produced there. And you can definitely see the bubbles, right? No doubt about that. You hear that? That's always fun. Sounds like a little puppy. So that's our single replacement reaction. That's our single replacement reaction. So this, because it was such a big piece of zinc, it would take a really long time for it to basically go to completion and completely dissolve in this solution. It would take quite a while, so we're not going to see it right now. Okay, but you can see that the hydrogen gas is being produced. Okay, so that's the single replacement reaction. Also, one more thing I want to add. This is warm, very warm. So there's definitely heat being released here. So this is an exothermic reaction. One more thing I want to show you. This is what it started out like, nice and shiny. This is what it looks like now. It is definitely not as shiny. It's kind of dull and darker looking. Okay, so this is before and after. Okay, the last one we're gonna do is our neutralization reaction. Okay, so these are our two chemicals that we're going to mix together. We've got sodium hydroxide, which is a base, and we've got hydrochloric acid, which is obviously an acid. And you can tell on your paper that HCl is an acid because it starts with hydrogen. You can tell that NaOH is a base because it ends in hydroxide. And as you guys go on to take AP and college chemistry, you'll know that the definitions of acids and bases are a lot more complicated than that. It's not as simple as just starting with hydrogen or ending in hydroxide. But for 8th grade, that's where we're going to just draw the line. If it starts with hydrogen, it's an acid. If it ends in hydroxide, it's a base. Okay, that's how you can identify a neutralization reaction. All right, so what do these look like before our reaction? They're both clear liquids. Okay, so I'll show you This is our sodium hydroxide. It's a strong base. Strong bases are also dangerous, just like strong acids. I feel like that's a misconception. People think that for some reason the word acid is a scary word, but the word base is not. It just depends on a lot of different things. And then here's our hydrochloric acid, which we saw earlier. This is what we mix with the zinc. It's also a clear liquid. I'm gonna add it right here. And what we're gonna do, because we're not gonna see any color change or smoke or anything like that with our typical signs of a chemical reaction. So instead what we're gonna do is I'm gonna show you that the neutralization reaction is happening with this pH paper. So pH is a scale that we use to measure how acidic or basic a chemical is, okay? So this is like orange right now. If I dip it in this, it turned pink. And there are all these colors right here to match it up with. So I would say that this has a pH of about 1. I would say that's about 1. That must be our hydrochloric acid, because if your pH is below 7, it's acidic. If it's above 7, it's basic. So this one, this pH paper tells us, hey, this is very acidic, okay? Now what we're gonna do is we're gonna test our base, our our sodium hydroxide. And this one is very purple, so this one's very basic. It has a pH between 12 and 14 probably, so that's a very basic solution, okay? So when we take our acid and our base and we mix them together, remember it always makes water and a salt. Okay, and the salt is not, remember in chemistry class, the word salt just means ionic compound. The salt we're gonna make right now though is actually table salt, NaCl. So this should just be dissolved salt water. Let's see if the pH comes out neutral, because it should come out neutral, like a yellowish greenish. Let's see. Hey, it worked. Okay, so this turned out neutral, somewhere in between the two. So it made salt water. All right, now this only works if you mix the acid and the base in perfect molar quantities, meaning basically the correct amount of acid for the correct amount of base. Because if you have too much acid, it's still gonna be acidic. If you have too much base, it's still gonna be basic. All right, the next thing I'm gonna show you guys is the precipitation reaction. So the precipitation reaction, we're going to mix sodium sulfate with barium nitrate. And remember, in a precipitation reaction, the two metals are gonna swap places and it's gonna form a precipitate. And if you remember, a precipitate is a solid that is formed in a chemical reaction. So here's my sodium sulfate and here's my barium nitrate. They both just look like clear liquids, okay? I'm gonna add some to this test tube with this pipette. I'll show you. Clear liquid. This is our sodium sulfate, it's clear liquid. Okay, I'm gonna use a different pipette for my other one so I don't cross-contaminate. This is my barium nitrate. It's also just a clear liquid. And let's see what happens when I mix them together. Ooh, can you guys see that? Is it still a clear liquid? No, it's very cloudy. It's cloudy. And that cloudiness is because the precipitate has formed. And the precipitate is a solid. So we're gonna let this sit for a while and we're going to let it settle because there's a bunch of little dusty precipitate particles in here. If we just let it sit for a while, it's gonna settle and then we'll be able to see the two different, basically the solid settled on the bottom and the just the liquid on top, okay? Okay, I let this sit for about 15 minutes and look what happened. You can see that the precipitate settled to the bottom and just the liquid part, the water with the spectator ions in it is just sitting there at the top. So that white stuff you see is a solid precipitate that has settled to the bottom. On this paper, hopefully you should have your pre-lab filled out. You should have these parts filled out. And then on the back of your paper, you're going to fill in what the products were for each reaction. If you're not sure how to do this, I gave you some hints throughout the video, but you can also look at page 24 for help to figure out what it will produce. Then you need to balance. So make sure when you write your products, you leave spaces like this so you can balance with coefficients. Then you need to answer these conclusion questions, okay? Metal. Okay, I'm gonna put it in and let's see what's gonna happen. Okay, well that didn't work. I need stronger edge cord.